Sorry about that, my phone being dumb. All right, so right back to it. I got my Pythagorean identity. I want to make the left-hand side here, my right-hand side look like the left-hand side. So right now I've got sine squared plus cosine squared equals 1. I want to make it look like sine squared of x minus 1. Well, how will I do that? Well, first I need to get this 1 to the other side, right? Because it's sine squared of x minus 1. So I need to subtract by 1. So then I'll be subtracting by 1. And I'll come to this side over here so I don't run up to too out of space there. So I've got sine squared of x plus cosine squared of x minus 1 equals 0. Do I have this right here on one side? No, I have a cosine here that I need to get rid of, right? So I'll come in here and I subtract by a cosine of x squared of x. So now I have sine squared x minus 1 equals negative cosine squared of x. My question is, does this side match this? It does. Well, what does this sine squared of x minus 1 equal? It equals negative cosine squared of x. So I would come over here, replace sine squared x minus 1 with a negative cosine of x, and I have now simplified. Now coming down to number 24 here. Number 24 has cosecant of b over sine b plus cosecant b times sine of negative b. Remember, one of your big strategies when solving for these is to first get everything in terms of sine and cosine. So let's do that, shall we? If we get everything in terms of sine and cosine, first let's get cosecant. Cosecant is the reciprocal of, remember? Yes, it is the reciprocal of sine. And specifically, so it would be 1 over sine. So rather than this being cosecant b over sine b, it's now going to be 1 over sine b over sine b. All I've done is replace cosecant of b with 1 over sine. That's it so far. Then come over here, plus, let's put cosecant in terms of sine. So it becomes 1 over sine of b times sine of negative b. In this case, it's sine negative b over 1. Let's go ahead and simplify. So let's get this complex fraction to become 1. And then let's get this also to do some simplifying. So here, this, remember how we do complex fractions, is you flip the denominator and multiply. All right, flip the denominator and multiply. So now, instead of it being sine b over 1 on this side, now instead of being 1 over sine b, that's going to become 1 over sine b. Let me come over here, by the way. 1 over sine b times 1 over sine b. All I've done is taken this, flipped it, and then multiplied it by here, which I haven't actually multiplied yet, just wrote it side by side. Then plus over here, sine of negative b, if you remember the negative angle identities, is negative sine b. All right, so sine of negative b, sine of negative b is equal to negative sine b. So this becomes 1 over sine b times negative sine b over 1. All right, let's go ahead and combine then. So I have 1 over sine b times 1 over sine b. That's going to become 1 over sine squared of b. Then my two sines here cancel out. I'm left with a negative 1. Because this becomes a negative 1. So I have 1 times negative 1, which is negative 1. Now, one thing I've got to do is get common denominators between these two expressions. Well, my common denominator, I'll go ahead and just do this 1 over 1. My common denominator between, well, here, let me help you out here. Common denominator here between sine squared and 1 is going to be sine squared of b. So I need to multiply both sides by what it needs. Well, this side doesn't need anything, right? Because it already has sine squared of b. Right hand side, I got to multiply by sine squared b over sine squared b. In order to get common denominators here. So now I have 1 minus sine squared b over sine squared b. And to the side, let me show you what went down right there. So I've got 1 over sine squared b. And when I multiply this over here now, it's going to be minus sine squared b over sine squared b. So once I gained common denominators here, these are both the same denominators, common denominators. You write it under one fraction and you combine their numerators. That's all I've done. I've taken these two separate fractions and made them into one because I have common denominators. Then one last thing, I need to simplify my numerator by using my Pythagorean identity. And 1 minus sine squared of b is cosine squared of b. So now I have cosine squared b over sine squared b. And is there any identities that use cosine over sine? In this case, it's cosine squared over sine squared. Yes, it would be cotangent. The reason why I know that is it's cosine squared over sine squared, or just if you think about it this way, it's cosine over sine. Cosine over sine is cotangent. In this case, we have squareds as well, so it'd actually be cosine over sine squared. All right. Now, moving to number 25. Number 25 is a step different. Number 25 says verify each identity. Remember, when I see verify, I've got to make one side of my equation sign look like the other side. All right. I got one side make look like the other side. In this case, I'm going to make this left-hand side look like the right-hand side. All right, that's my goal. Left-hand side look like the right-hand side. So when I come in, I've got cosine squared x plus 2 sine squared x. So I need to start plugging in some identities. I need to start reworking some things, configuring some things. I know that cosine squared of x is part of my Pythagorean identity, is it not? My Pythagorean identity is sine squared of x plus cosine squared of x equals 1. Well, if I want to plug in what cosine squared of x equals right here, I want to plug in whatever this is into here. I've got to get cosine of x by itself. So let's do that. The way I do that is go minus sine squared of x. So minus sine squared of x. So cosine squared of x is actually 1 minus sine squared of x. So what I'm going to do is I'm going to take what cosine squared x equals and plug it in. So when I do that, I'm now left with 1 minus sine squared x plus 2 sine squared x. Remember, I'm trying to make this side look like this side. Well, where do we go from here? Can you see it? Well, if you notice, we have like terms right here. We have a sine squared, we have a sine squared. So I can combine those together. The 1 can't do anything, I just leave it there. So I have a negative 1 sine squared x, and I'm adding 2 sine squared x. So what would that give me? It would give me a positive 1 sine squared x. And when you look at that, we have what I was supposed to get. Yay! I'll hurry along.